Hello, welcome to math class once again. My name is Olujimi Gabriel. Today we're talking about standard form. Now, before we go into today's topic, I had a correction for previous assignment. You were given p raised to power minus 2 divided by p raised to power minus 7. Like I said, when you have a negative index, then it's simply as p raised to power 2 divided by 1 all over p raised to power 7. You introduce inverse to remove the minus you have in the index. Now, this is it here. 1 over p raised to power 2 divided by 1 over p raised to power 7. You can change this division to times by interchanging what you have in the denominator and numerator. Here is what we have. We have 1 over p squared times p raised to power 7 divided by 1. And when we're dealing with index that have to do with negative, with division, we subtract, which is p raised to power 7 minus 2, which is equals to p raised to power 5, as you have seen here. Now, look at number 2. We have a raised to power minus 2 times a raised to power minus 3. And we have, when you rewrite a raised to power minus 2 as 1 all over a raised to power 2 times 1 all over a raised to power 3, which is equals to 1 all over a raised to power 2 times a raised to power 3, which is equals to a raised to power 5. And that can be written as a raised to power minus 5. Then number 3, we have 2a raised to power minus 1 times 3a raised to power 2. You can see the bracket is affecting the content, while this one is for a only, which is why we have 2 raised to power a times 3a times 3a. When you have the power to be 2, it means you multiply the content in 2 places. That is 3a times 3a, which is equals to 18a. That is that on indices. Now we move straight to the objectives. That is, at the end of this class, you should be able to express any whole number in standard form. Express decimal fraction in standard form. Also, you should be able to round up numbers to a given number of significant or decimal places. Now, the first one we deal with is number that are equals or more than 1. It is possible to express numbers like 1,000, 1 million, 1 billion as power of 10. For example, when you have 1 million, you count the number of zeros that you have there. Number of zeros mean number of 10 that you have in that number. Like now we have 1, 2, 3, 4, 5, 6. That means we have 10 multiplied in together. 10 numbers multiplied together. We have 10 multiplied in 6 places. This is 10 times 10 times 10 times 10 times 10 times 10. That means we have 10 raised to power 6 when we write it in an index form. The first thing you do, you count the number of zeros that you have there. If you have 6, that means you multiply 10 in 6 places. That is 10 times 10 times 10 times 10 times 10 times 10, which will be equals to 10 raised to power 6, as we have been doing with indices. Other numbers can be expressed as product of 2 10, one of which is power of 10. Now, let's move to the next slide. For example, when you have 2 million, you can see 2 million can be written as 2 times 1 million. Now, counting the number of zeros, we have 6. That means we can have 2 times 10 raised to power 6. We write this in standard form. Like we write it in an index form, that is 10 raised to power 6, multiply by 2. You can see we have two separate numbers. One is signed separately. This one is an index form. This one is written in an index form. The same thing with 2,500,000. And in 2,500,000, you have 5 zeros, just like what you have here, 1, 2, 3, 4, 5. But you can see we have 1 million here because the number is more than 2 million. That is why we call it 2,500,000. Now, we have 5 zeros here, but here we are using 6 zeros. When you count 1, 2, 3, 4, 5, when you count the next number with it, then we introduce a decimal point. 1, 2, 3, 4, 5. When you count 5 with it, it will be 2.5 to make up for 6 zeros. That's why we are having 2.5 times 10 raised to power 6. If I happen to count 2 with it, it will be 25 times 10 raised to power 7. But in this case, I'm counting only 5. It means my counting stop at 5. That's why I'm having 2.5 times 10 raised to power 6. Look at this one also. How many zeros? We have 8,600,000,000. And in that, because the number is more than 8 billion, we have extra 6 million on it. We have how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. Now, you can see it should be 10 raised to power 8. But because I'm counting 6 with it, it will be 8.6 times 1 billion. No, 9 zeros will give you billion. Now, that is 8.6 times 10 raised to power 9. You count the number of zeros you have, it tells you number of tens you have in that number. Now we have 8.6 times 10 raised to power 9. If I happen to count 8 with it, it will be 86 times 10 raised to power what? 10. Fantastic. Now, these numbers, 2 times 10 raised to power 10, 2 times 10 raised to power 6, is what we call standard form. These numbers are all in the form a times 10 raised to power n. A is a number that between 1 and 10, and n is a whole number. Now, look at example. The following numbers in standard form. You have to express this number in standard form. Look at, we have 60,000, 650, 480 million. We have 480 million. Then we have 320,000. Now, the first one is 60,000. This is 1, 2, 3, 4. Now, you count the number of zeros you have there. 1, 2, 3, 4. That is 6 times 10,000. Now, when you count the number of 0, 1, 2, 3, 4, that shows you have 10 multiplied in 4 places. That will be 6 times 10 raised to power 4. Now, the second one is 650. Now, how many zeros am I having here? In 650, I have 1 0. But if I count 5 with it, that means I will have to introduce a decimal point, which is zeros. That means 6.5 times 100. The number of zeros will tell you what you have. For instance, if I have 1 0, that means it is 10. If I have 2, that means it is 100. If I have 3, that means my number is 1000. Now, 650, that is 6.5 times 100 because I counted 1, then I added 5 to it. That is 2. That will be 6.5 times 100, which is equals to 6.5 times 10 raised to power 2. Now, look at it. We have 480 million. Now, when you count the number of zeros you have there, you have 1, 2, 3, 4, 5, 6, 7. I have 7 number of zeros. But if I count 8 with it, I have to introduce a decimal point, which is 4.8. That means I counted how many zeros now? 8. That is 100 million. That is 100 0.00000. Now, when you count the number of zeros you have 4.8 times 10 raised to power 8. That is how to express a number in standard form. Now, look at this 320,000. Count the number of zeros as well. I have 4 zeros here. When you count 2 with it, you have to introduce a decimal point, which is 3.2 times 100,000. That is 3.2 times 10 raised to power 5. You can see how simple it is to represent a number in standard form. Now, we can also change from standard form to ordinary form. Look at the first one. We have 4 times 10 raised to power 4. We can express it in ordinary numbers like what we have here. Now, look at. You put 4, that will be 4 times, how many zeros? 4. 1, 2, 3, 4. That means we have 4 times 10,000. 4 times 10,000, which is 40,000. The same thing applies here. How many zeros do we have here? We have 4.3 times 10 raised to power 4. That is 4.3 times 10,000, because we have 4 zeros there. When you multiply that, you have 43,000. Look at again. When you count 1, 2, 3, 4, that means 4.3 times 10 raised to power 4. Now, 7.8 times 10 raised to power 7, that means you are using how many zeros? When you have point, that means you are using 8 zeros, which is 1, 2, 3, 4, 5, 6, 7. Because you are using point, you have to use 8 zeros to remove the decimal point. That means our answer is 78 billion. Now, moving to numbers that are less than 1. The one we first treated is equals to 1 or more than 1. Now, decimal fractions such as 0.01 and 0.00001 can be expressed as the powers of 10. Now, the one we deal with, it is positive numbers. Now, look at 0.001. Look at, after the decimal point, you have just 2 zeros with 1. What we do is 1. You find the reciprocal. That will be 1 divided by, you count the number of zeros, 1, 2. When you join the 1 with it, it will be 1,000. That means you have 3 zeros. I take it again. We have 0.001. What you have here, you put it, then you put a division line. Then count the number of zeros you have there, which is 1, 2. You have to count the numbers with it also, which is 1, 2, 3. That will be, you have 3 zeros. That will be 1,000. Now, you have to write it in an index form. This should be 3, and this should be minus 3. It's a mistake here. Now, when you count the number of zeros, it will be 1 all over 10 raised to power 3. Now, from our indices, we know 1 over 10 raised to power 3 can be written as 10 raised to power minus 3. The same thing you apply here to get your answer. You can see from decimal fraction to indices. You can also express that in standard form. Thus, any decimal fraction can be expressed in standard form. Now, look at these examples. We are to express 0.008 in standard form. Now, look at what you have here. You have 8. Put 8. Write the division line. Now, count the number of zeros you have there. 1, 2. When you add 8 with it, you have 1, 2, 3. Is that okay? Now, 8 divided by 10 raised to power 3. Now, when you write 10 raised to power, you have 1 divided by 10 raised to power 3 can be written as 10 raised to power minus 3. Because 1 is ordinary number, while 1 is an index number. So it will be 8 times 10 raised to power minus 3. This is an ordinary number. This is indices. So you express this as a standard form. Now look at this one also. 0.00003 can also be expressed in standard form. Look at, you have 3 divided by, how many 0 do you have there? 1, 2, 3, 4. With the 3, it will be 5. That will be, we have 100,000. Now count the number of 0 and write it in an index form. You have 3 divided by 10 raised to power 5. Now, you can bring 5 up. From our law of indices, it will be 3 times 10 raised to power minus 5. The same thing also applies here. You can see it will be 2.5 when you stop 1, 2, 3, 4. When you stop at 2. But when you join 5 with it, it will be 25 times 10 raised to power 5. But because I stop at 2, it will be 1, 2, 3, 4. That will be 2.5 divided by 10,000, which can also be expressed as 2.5 times 10 raised to power minus 4. Now, express the following in standard form. We have 0.1234, 0.0007. Now look at 7 divided by 1, 2, 3, 4. When you count 7 with it, it will be 100,000. That will be 7 divided by 10 raised to power 5, which is equals to 7 times 10 raised to power minus 5. The same thing also applies here. You can see 1, 2. When you stop at 7, it will be 7.5 times 10 raised to power 100. That is that. Now, here's another one. 0.000022 can also be expressed in standard form. Just count 1, 2, 3, 4, 5, 6, 7. Now, you add 2 with it. Then you introduce a decimal point. That is 2.2 divided by 1, 2, 3, 4, 5, 6, 7, 8. It should be 8. 1, 2, 3, 4, 5, 6, 7, 8. This one should not be there. Now, that will be 2.2 times 10 raised to power 8. Now, when 1 over 10 raised to power 8 will be equals to 10 raised to power minus 8. That is why we have 2.2 times 10 raised to power minus 8. Just count your 0. How many 0 do you have there? It should be 8 and not 9. And this one should be 10 raised to power 8 and not minus. It is when you introduce minus, then 1 up will go away. Now we have this also. 1, 2, 3, 4, 5, 6. 6.3 times 1, 2, 3, 4, 5, 6. That will be 6.6 times 10 raised to power minus 6. That is how to express a decimal fraction in standard form. Now, express the following number as decimal fraction. That is that. You can see, still the same thing to what we did here. We are to express from standard form to ordinary form. Now we have 9 times 10 raised to power minus 4. Now, this could be 9 times 1 all over 10 raised to power 4. You can see, you rewrite this as this, then you have 9 divided by 10,000, which is equals to 1, 2, 3, 4. That is how to express in an ordinary form. It's just the reverse of what we were doing before. You know, we express from decimal fraction to standard form. Now we are now moving from standard form to decimal fraction. Is that okay? 9.4 times 10 to the power minus 4, which will be 9.4 divided by 10,000, which because we have 4 zeros. Now, you just have to write 0 points, then you count your zeros. 1, 2, 3. Because we have 9.4, that means you stop at 9. 9. That will be 0.0094, which is what we have here. The same thing applies to 5.3 times 10 raised to power minus 7, which is equals to 5.3 times, this is 10 million, because we have 7 zeros. Then you input these 6 zeros before 5. 1, 2, 3, 4, 5, 6. But we have 7 zeros. The next one will be 5. That will be 5, 3. Now, significant figures. Significant figure begins from non-zero digit. From non-zero digit at the left side of a number. Now, recall, we know number from 5, 6, 7, 8, 9 are rounded up. That is, you turn them to 1 and add it to the previous number before, to the number before them. And if they are 1 to 4, they are rounded down. That means, that is, they are changed to 0. Now, look at this example. We have 546.52. You can round it off to one significant numbers. But before you do that, always check. Now, look at 546.52. We want to round it off to one significant figure. That word could also mean important numbers. The word significant figure. Now, look, you have to start from the first number. Since we are looking for one significant figure, before you conclude, look at the next number. Are you supposed to round up or you round down? If it is 4, then you round it down. You turn them to 0. Number after it, everything becomes 0. That is why we have 500. Now, since this one is to be rounded down, then you turn it to 0. Every number after it becomes 0. That is why we have 500 to one significant figure. If to two significant figure, like what we have here, that means you count the first two numbers, 1, 2. But before you conclude, look at the third number. Are you to round up or you round down? Now, this one is more than 5, more than 4. That means you round up. You turn it to 1 and you add the 1 to 4, which will be 55. Now, after that, every number after these two numbers becomes 0. That is why you have 550 to two significant figure. Now, you say significant figures start from non-zero. That is why we have 55. Now, to three significant figure, you can see I've shortened it to SF. Now, you count the first three numbers, 5, 4, 6. But before you conclude, look at the next number. Are you to round up or you round down? It's also 5. That means you round up. You turn this 5 to 1, add it to the 6. It becomes 547. Now, every other number becomes 0. That's why we have 547 to four significant figure. Now, to 3. Now, to four significant figure, look at the first four numbers. But before you conclude, look at the next number. Is it up to 5 or below 5? If it is below 5, then you round down. That is why we have 464.5 to four significant figure. That is how to do that. Now, here are the example for you. Look at, to one significant figure, look at, you have 8 here. 8 is the first non-zero number. Now, to one significant figure, now, before you conclude, look at the next number. It is 0. That means every other thing becomes 0. You have 8. Now, to two significant figure, After 8, you have 0. But look at the next number to 0. You said the first non-zero. So we have non-zero, which is 8. The next number could be any number from 0. Now, look at the third number. Is it up to 5? No. If it's not up to 5, that means our two signal figure will be 8.0. 0 is also a number, only when it is not starting. But if it's starting, we move to the next non-zero numbers. You follow the same trend for all the remaining ones. Now, look at this one. The first non-zero number is 9. Before we can choose any number, the first non-zero number that is not 0, it is 9. That means our one significant figure will be 0.09 because the next number is not up to 5. So every ordinal number after 9 becomes 0. That's why we have 0.009. Now, to two significant figure, we have, count the first two non-zero number, which is 92, 0.0092. Now, the third number is 5. That means you round it up. You turn it to 1 and add it to 2. It will be 92, 93. That is why we have 0.0093. Now, decimal place. Decimal place are counted from the decimal points. Zeros after the point are significant are also counted. Now, 14.909. Now, 14.9028, we can round it off to one decimal place. That means the first number after the point is what we are looking at now. That is 14.9. Now, to two decimal place, the first two number after the point, but before you conclude, look at the next number. If it's to be rounded up or to be rounded down. But in this case, this one is to be rounded down. That means every other number after them becomes 0. These are our two decimal places. The first two number after the decimal point. Now, the first 3 points after the decimal point. Now, we have 14.9028. Now, 1, 2, 3. But before you conclude, the last number is 8. That means you round it up. You turn it to 1 and add it to 2. That will be 14.903. That is how to round up in decimal places. Here's another one for you to do. Look at. They are the same thing. Just know, look at. To one decimal point, the first number after 0, after the decimal point, you can see is 1. The first two number after 0, but we have 0.0072. Now, these are the first two number after this decimal point. But before you conclude, look at the third number. We have to round this up. That means you turn it to 1 and add it to 0, it will be 0.1. That is why we have 0.01 to two decimal place. This one also, to 3 decimal place, you look at the first 3 numbers after. This one should be 0. The first 3 number after, it will be 0.070. That is that. Assignment for you. Express the following in standard form. You have to round off this one to 1 decimal place, 2 decimal place, and 3 decimal place. Round off to 1 significant figure, 2 significant figure, and 3 significant figure. That is that. Now, back to this one should be 0.072. 0.072. These are the first 0.07. That is the first 3 numbers that we have there. Now, till I come, summary, significant figure begins from the first non-zero digit at the left of a number, just like what we have done before. Now, decimal places are counted from decimal points, just like what you have here. Now, for further reading, you can get the Junior General Mathematics textbook from page 29 to 31. Till I come your way next time, enjoy the rest of your day, and thank you for your time.